Awesome. So very happy to be here on this awesome Monday, and I'm excited to talk about detection engineering and Kubernetes environments. So just quick, who am I? I'm Dakota Riley, current principal security engineer at Acquia, current AWS community builder, and I wear a lot of different hats, cloud, Kubernetes, security automation, all sorts of stuff, all sorts of fun stuff. Very proud cat dad, 2 cats. I should have put a picture in there. I didn't. And outside of work, I have a gaming addict habit that I haven't kicked yet. I also enjoy different types of fitness, jujitsu, hiking, running, lifting. So yeah. So just a quick tidbit about my employer who I'm here representing today, Acquia. So we are a service disabled veteran owned small business, basically a boutique consultancy, and we focus on cloud and cybersecurity transformative initiatives. We actually just got our AWS Advanced Tier Partner status. And a little more relevant to the talk, we do a lot of Kubernetes security work through the form of some of the various DoD and federal software factories, which are basically built on Kubernetes. So just a quick intro, kind of the agenda of what we're going to go over. So the thing I love to start with when we talk about kind of detecting bad things or malicious activity is why you should care. Why does this deserve a spot in your probably likely busy detection engineering backlog? From there, we'll talk about what types of data are available and like which ones we should think of just from like a high level mental model. There's really 3 I'm going to focus on, and that's syscalls, application logs, and Kubernetes audit logs. The first 2 I'm going to kind of glance over at a high level just because I don't feel like you can do a talk about detection engineering and Kubernetes clusters without really kind of giving justice to those things. But we're really going to dive deep into some Kubernetes audit logs today. And then, finally, towards the end of the talk, we're going to round off with how do we get started generating our own detection cases that are specific to our environment. And we will actually look at some logs and kind of pseudo write some detections against them and figure out how to make them high fidelity. So great. Why should you care, right? And I always want to caveat this first with you have to look at this through the lens of your org's threat model and risk posture, right? The answer to this question is going to be very different if you're like a global SaaS company that has like a global presence and your stack's all CNCF, Kubernetes, versus maybe you're just a completely different type of org, right? So you have to work backwards from your own org context. But I guess the 2 real data points I wanted to bring, right, is that there's publicly available data of, attackers like attacking Kubernetes and like in a Kubernetes native way, I guess, for lack of a better term, right? And the 2 I wanted to point to in the talk are the MITRE ATT&CK enterprise matrix for containers. And so just very high level overview, the MITRE ATT&CK matrix basically consists of TTPs, right, of just different techniques. And there's an entire containers matrix. And the criteria to get a sub-technique or technique as a part of that matrix is it has to be observed in the wild. And if you look at the containers matrix, I'll talk a little bit about it later. It's very general, but there's plenty of Kubernetes specific sub-techniques in there. The other that I actually saw when I was building the talk that was a little more recent, there was a kind of academic study that came out of University of California, Santa Barbara, that was basically they took and built honeypots that emulated common container orchestrators. Like OpenShift, Kubernetes, and they exposed them to the internet to see what would happen, right? And specific to Kubernetes, what they found was that in an automated fashion, there were attackers that were actually trying to crawl the API, look at the available resources, and even in some instances create kind of malicious resources, right? Like a certificate signing request, like trying to elevate their privilege with, credentials. The thing that really stood out to me as a practitioner that was really interesting is in there they also observed people trying to interact with the kubelet agent, which kind of shows a level of advanced understanding. They know more than just the API, right? So awesome. So talking about the kind of high level categories of data that are available to us for kind of a detection engineering perspective in our clusters, right? I didn't want to oversimplify it too much, but I wanted to break it down to like kind of 3 high level categories, right? So surprise, surprise, host level data still matters, right? Because ideally, depending on what type of flavor of Kubernetes you're using, you still have compute under your nodes, right? It's not really the focus of this talk, but it's just conceptually important to understand that that's still there. I'm also not advocating to throw all your endpoint security tooling on those nodes. It's going to be a bad time. Moving on, right? Specific to the cluster, right, is really the Kubernetes audit logs, which is really the meat of this talk. Honorable mention to cloud provider logs. Some of the managed flavors of Kubernetes have different integrations, and there's like auth logs that come out of those. There's also the CSP's control plane logs, right? And then finally, which we're actually going to talk about first before we dive into the world of Kubernetes audit logs or application logs, right? The things that are actually running on your clusters. And in those two categories, we have syscalls and logs that actually come from the applications themselves. So with syscalls, right? What are syscalls, or what do they tell me? And the easiest way to describe them is they just tell you what's going on inside your containers, right? Hey, why is my container making requests to a Monero mining domain, right? That's really strange. Maybe I should do something about that. But syscalls are basically just OS level operations, right? How your code, say if your code is reading or writing files, starting processes, or networking operations, right? Those are going to be, you're interfacing with syscalls to make that happen. Even if you're not directly writing them yourself, your code is doing that, or the underlying libraries, right? And the point of this here is that most of the, typically you would call this runtime security. Most runtime security tools either consume this or this and other data sources to actually detect these bad things, right? And even though this could be its own talk, right? But my point here is don't build this yourself, right? If you're smart enough that domain to do that, definitely go become a contributor of like Falco or Tracy that I mentioned, but there's really good open source tools here. Even the cloud service providers are starting to break into the space with like managed offerings like EKS Guard Duty Runtime, or GCP Security Command Center just started a capability for this as well. So surprise, surprise, even though I just said buy or procure something, that doesn't mean that there's not any detection engineering work here to be done, right? These alerts are still going to need contextualization, like they're not going to have the context outside of the container they're detecting on, right? Or your greater org. Prioritization, really important. That'll kind of dive in when we start talking about detection cases, and then getting them to the right place, right? And generally speaking, a lot of this tooling is just very noisy based on the nature of what it's doing, right? It's basically taking signatures from syscalls in an attempt to detect malicious activity. A practical example, is I've had to deal with this where tuning rule sets by purpose or environment specifically. So in the real world, we had clusters that were hosting CI pipelines, and the runtime behavior of a CI pipeline is very different than, basically like a production application, right? One is literally pulling dependencies, compiling, maybe doing other different things, versus a lot of times you're just running a binary, right? Or something of that nature. And as such, if you apply that type of rule set to one or the other, you're going to get a lot of false positives. So it's very important to tune those to the environment. All right, so application logs, right? As opposed to syscalls, this is what is your application actually writing to hopefully standard out, right? There's known patterns to capture this stuff, right? Tools like FluentBit that can enrich it with like context. Say if you're going to send this stuff to a SIEM, you'd be able to trace back where or what its relationship is to the cluster that you got it from. The important thing I would say here is to not just go and consume all of these. And if you're experienced with detection engineering or logging or any other domain, you probably already know this. You want to approach them case by case. And the first case I would definitely say is there's some security tools you run in your cluster that you actually have to obtain their logs this way, or that's one way you can do it. There's also, it's also worth looking for particular infrastructure tooling that might yield security relevant logs, like some of these GitOps tools. They do deployments using a privileged service account, and they pull for different sources so that can help you tie together the full picture. And finally here, if you're a security team separate from your ops team, ask your ops team first. They're probably doing this in some capacity that you can go to them and be like, hey, I want to use this for this specific purpose. All right. Probably my favorite half of the talk, right, is Kubernetes audit logs. So we're going to talk all about these, but at its core, Kubernetes audit logs are basically just your interactions with the control plane. So when you're deploying your application to Kubernetes, basically you're creating, reading, updating, deleting resources against that API, and the audit logs will tell that story of what actually happened there. Specifically to like bare metal Kubernetes, right? They're not enabled by default. They have to be enabled with an API server flag that specifies what's called an audit policy, which is that interesting looking code blob you see on the other side of the screen. At a high level, an audit policy basically just says what I want to log and to what level of detail I want to log it, right? Being a little more specific there, there's like kind of two, outside of resources and paths and stuff like that, there's like two little parameters you can play with there. Log levels which basically says what level of detail. Do I want just, who it came from, their user agent, things of that nature, or do I want to see the full raw request or the request and then how the server modified it? A little later in the talk, we're going to actually look at a raw log by itself. I'm going to call back to this so you can see how changing those would actually affect the audit log that's generated. And then stages. And I'm also going to talk about this one a little later too, but the easiest way to explain this is that Kubernetes actually, if you turn all three of these on and you make a single API call to say to create a pod, you'll get 3 audit logs of the request basically traveling through its like cycle of being handled. I've got some opinions on the security value of which one's more important, but I'm going to save that. So I imagine there's probably quite a few of you in here who have worked with the CSP managed flavors of Kubernetes, and you're probably wondering like, hey, Dakota, I've never seen that thing you just showed me. Are you just making that up? And the answer is no, and there's probably a really valid reason if that is you, and that's because the CSP abstracts that away, right? They don't provide direct access to the API server flags, they manage it for you. And then you would call their API to enable or disable them in certain cases, right? The nice thing about this and why it's relevant for this talk is if you want to detect something, it's pretty good to know that the thing you're trying to detect is going to generate a log with the appropriate level of information for it. And the cloud service providers actually make their audit policies public, or the code they use to generate them in the cases of GKE and AKS. So awesome. Very exciting stuff. We're going to look at an audit log and what the structure is. But before I do that, one thing I really appreciate about the kind of Kubernetes ecosystem is most of the APIs are very well documented. And that's also true for the event audit log event schema. You can actually literally go straight into the documentation and basically see this exact schema, probably with better detail than I'm about to just talk about. So great. We're looking at the first half of an audit log. So I'm not going to talk about every single field. I'm more going to kind of break it down into high level categories because we'll dive in a little more when we start looking at, creating our detection cases. But this is essentially the first half of an audit log for creating a pod, right? And if you're familiar with logging in any capacity, you're going to see fields that immediately make sense to you, right? Likely verb, stage, source IPs, user agent. All of those would fall under that metadata category, right? So if you have metadata turned on for a specific request type, you're still going to see all these things. The one I'll call out is object ref, which is also a metadata field. It's basically just saying what object in the Kubernetes API am I targeting, right? In this case, I'm targeting a resource of pods in the default namespace, which is also bad, but that's a test, right? Moving on to the second half of the request, it's truncated, but there's a couple other fields too that are also still metadata, but the two I want to call your attention to here are request object and response object. These are very, very long because request object and response object, literally in this case, I've created a pod would contain that entire specification for the pod. And in the case of response object, you would get that plus how the server modified it. So if there's default fields or if you have an admission controller that changed it, those would all be included in there. And that's all subject to what level you've configured or the CSP is configured in your audit policy. Great. So while I was going through and generating kind of events for this talk, I also wanted to look at how the different cloud service providers manage flavors of Kubernetes handle this, because there's no guarantees they do it the same, right? The nice thing I found is like EKS, just standard Kubernetes and Minikube, which you can run locally really easily, all follow that consistent Kubernetes event structure. The outlier here is GKE. They obviously consume audit logs on the back end, right? Because you can see their audit policy, but they're transforming it to like kind of I guess it's normalized across their platform, but it's an interesting edge case to be aware if you're doing Kubernetes detection engineering in a Google environment that you can't rely on the assumption that they're going to be exactly the same. So another important tidbit here is that all of the cloud service providers allow you to use your CSP credentials to call the cluster APIs if you're using managed Kubernetes, right? And why that's important for detection engineering is you need to know how this manifests itself to actually trace back the full chain of identity of who did something, right? Not to be confused with workload identity. This is your cloud service provider credentials authenticating to the cluster, not cluster workloads authenticating to the CSP. So 2 quick examples of that. There we go. So again, a truncated EKS audit log where you can see the user field, and there is quite literally an extra key that contains the attributes relevant to, in this case, this is an IAM role that made a call against an K8s cluster, where you can see the role ARN, the session name, which in this case of SSO is really important to identify it. The other giveaway here is if you look at the UID, you'll see a string that contains AWS IAM Authenticator, which means the AWS IAM Authenticator plugin authenticated this request. So GKE is a little simpler, and I made the use case intentionally a little simpler, but there's just an authentication info field. And this was a call made with just a Google account to a GKE cluster. And you just see the email address of the Google account in the field. So before we jump into talking about our detection cases, I just wanted to have some high level notes on audit logs and kind of pain points or interesting things I found. And the first is that it's important to understand that like, even if you ran a, EKS, GKE, Minikube cluster, whatever by itself and didn't create service accounts for pods or interact with it yourself, there's going to be audit logs generated because different Kubernetes components will actually call it to do things that they do. So it's very important to know. I don't recommend trying to tail those logs unless you're filtering them through something else. Calling back earlier to the request stage bit, I found from a detection engineering standpoint that request complete events really kind of get you 99% of the way there, just because there's a lot of duplicated information between request received and response started. But I found that that's probably for people developing new features or components of Kubernetes and being able to debug that. And you don't lose any information either because there's a handy request received timestamp in that event. And then finally, and this is a little bit of an opinion of mine, right? There's obviously, if you're using managed Kubernetes, you have limited control over this and they can get expensive, right? And I actually personally think there's a little room for improvement on the cloud provider side of the shared responsibility model here. AWS has kind of trended towards that, where they started recently classifying EKS audit logs as what's called vended logs. So that means you're eligible for discounts at certain volumes of pricing. All right, so let's talk generating detection cases, right? Or how we get started with this, or what we need to do to get started, right? And arguably, in my opinion, the most important thing on this list is understanding the norms in your environment, right? And in the case of Kubernetes, or really even cloud in general, like you should be asking these questions of how do we deploy? Like, are we using GitOps? Are we still manually deploying stuff? Is it a mix? Like, how mature is that? What does our SDLC look like? How are we organizing clusters, accounts? What tools do we use? What tools do our devs use, right? What tools do we not use and know that we don't use? And then how do we organize our clusters? What gets its own namespace? What gets its own cluster? What gets its own cloud account, right? And this is all valuable context that can be fed into either detections for deviations from those things, if you want to get really environmentally specific, or it can be used as context for when you're detecting like more kind of TTP style detections to like enrich them and make them higher fidelity to determine, is this actually malicious or is this somebody just doing their job? I have to give a shout out to like lots of the great adversary emulation tooling that's out there. So there's tools like Stratus Red Team, which literally has a Kubernetes plugin for emulating attacks against the control plane. Atomic Red Team is still really awesome for if you wanted to emulate attacks in a container itself. That's, it's not really designed exactly for containers, but it operates at that layer, right? And this one's a little debated, like pen test tooling, because there's sometimes where people really want to lean into what exactly are adversaries doing, but a struggle I've personally had is like when you work with like cloud and cloud native and stuff like that, there's just not a lot of data out there, right? So I think it's worth looking at the things that are in those tools and seeing if they're relevant to your environment and worth the time to build detections around, not just necessarily relying on only what adversary tooling does. Finally, threat modeling and attack trees are great. Obviously, I mentioned MITRE ATT&CK for containers and cloud. I wanted to also give a mention here to the Microsoft threat matrix for Kubernetes. And if you're wondering why I'm mentioning two different matrices, is the MITRE ATT&CK for containers matrix is built in a very general way that it can be applied to different container orchestrators. But if you're coming at this from being a practitioner, like you're familiar with Kubernetes and cloud and stuff like that, the Microsoft threat matrix for Kubernetes is actually written very much from that perspective, right? Written for Kubernetes. Awesome. So before we start looking at some detections and looking at some logs, right, I wanted to talk about some common mindsets or maybe pitfalls that I try to avoid or encourage people to avoid. And the first is, we already have a preventative control for this. And my answer to that usually is, great. How do you know it's working? And also, hey, this effectively makes this detection a canary, right? It should be really high fidelity if it fires and really prompt an investigation to why these things are not working, right? And a real world example that I can name here is, say you enforce trusted registries or container image signing from your pipeline. You should definitely detect deviations from that, right? Because that would be very suspect. Either something's not working, or even if it's not malicious, something is very interesting there that's worth investigating. And finally, and this one has some merit, but the X attacker would just do this instead. And I think this goes back to, you have to look at what's an appropriate kind of threat model or risk posture for your org, and just attacker sophistication varies, right? Like, not everybody is going to be targeted by super advanced APT, right? Attackers make mistakes too. All right, so now we can jump into our detection cases. So basically, just the way I carved these out is I grabbed basically a known TTP in Kubernetes, tried to highlight the exact legitimate use case for this thing, because most of these all have legitimate usages as well. Then tie them back to the tactic on the matrix. And then from there, the other slide, you will actually look at the log and see how we could identify this. And then we'll talk about what kind of organizational or environmental parameters would let us tune this to be higher fidelity. So for starters, this is production access via the exec command. So Kubernetes by default lets you use a command called exec to get either run commands and running containers without opening a port, or to get an interactive shell to that container. It's really handy for troubleshooting or break glass, but it also makes a very nice execution or lateral movement tactic. Say you're an attacker that found a kube config, or you got a service account off a pod you compromised. So looking at the log up there at the top, you could see, say if I was to just run, kubectl exec -i for interactive, and then my test pod, and then run bin bash for an interactive shell, would produce the following event. And so you're going to see, on this event, you'll see a verb to create, right? The key thing here to look at is in the object graph, you'll see resource pods, but you'll see a sub resource of exec. We're not creating a pod, we're creating an exec session on that pod. And where this one gets interesting to me is you can actually determine what actual command is being run by looking at the request URI. So if you look really closely, I know some of you are kind of out far in the audience there, you will see that there is a command query string parameter, and there's that URL encoded bin bash, right? You can also tell it's interactive there. From what I've seen, that doesn't manifest itself anywhere else in the event. So the detections I've written for this, I've had to actually parse that out of there and then, kind of interpret it that way. So great. We have a detection, and now it's firing on our devs who are just trying to troubleshoot stuff in the dev environment, right? So how do we make this high fidelity? I think the first and easiest stop here is, prod versus dev, right? What are your access patterns at your org? If they're really mature, right, then maybe scope it to being prod. Other things you can bake into are, is this an individual? Is this a service account for a pod? If it's an individual, are they on call? Is there an active incident? Because typically that's when this legitimate access gets broken out at more mature orgs, right? Other things like historical, has this credential ever done this before? That's always an interesting indicator there. There's a huge difference between an identity that's tied to a human that does this when they're on call versus a container that's been running for a year and has never done this and is suddenly trying to do this out of the blue. Awesome. So for our next one, right, if you've been in the container space in any form, this is probably not unfamiliar to you, but launching of a privileged container. So basically, Kubernetes allows you to launch containers that can ultimately access the capabilities of the underlying node or host. And there's, as scary as it sounds, there are legitimate use cases for this, right? Like runtime security tooling, ironically, is one of them. For all those runtime security tools I mentioned, they have to run in a privileged manner. Anything that needs to access underlying hardware or certain paths, things of that nature. But surprise, surprise, it's a privilege escalation tactic. If you're in a scenario where you have the capability to somehow deploy pods and you're able to set this flag and you don't have that access, otherwise you could technically escape to the underlying host. So again, kind of have to squint a little bit, but if you look at the event here, you'll see that basically we are taking a verb create event against the resource pods. And this is where this goes back to the audit policy, where in order to actually understand this, I have to have the request. I can't just have the metadata, right? And I would have to look at the actual specification that's provided in the container for looking for a key of security context, privileged true. So great. We've deployed this. How do we make it helpful, high fidelity, right? And the first and easiest step, in my opinion, is if you have the ability to, is to inventory all known valid use cases of privileged containers in your organization and just maintain like a kind of simple allow list that you know, if you have runtime security tooling and you know those images and know those image hashes, that's a great starting point, right? Other little knobs you can turn here is like, is it new or previously deployed? Environment level, I'm never going to stop harping on environment level because I think that one's really key. If you've got good hygiene and you know what kind of identity deployed it, right? A CI pipeline, human, and in this case, would it actually be an escalation of privilege, right? You know, I think it's really different for something that's already privileged to deploy this versus somebody that may have a limited bit of access and is trying to deploy this to elevate their own privilege. And finally here, there's similar privileged-like capabilities that you can also turn on that are not fully privileged that this also would apply to, like host path or host PID that basically just allow you to access process IDs or file paths on the underlying host. All right, for our final detection case here, we're going to talk about an attacker retrieving all secrets in the cluster. So this one was really interesting for me, coming from more AWS native land, right? But Kubernetes basically provides an out-of-the-box resource for storing secret values and providing them to your containers, right? And that's the legitimate use case for this. And the bullet point here of the data plane versus the control plane being fuzzy is why it was interesting for me here, and I'll show you why in the example. But obviously, this is a pretty juicy tactic for an attacker because, hey, I found a service account or a kube config. What secrets are in there and what systems are they to? Can I try them to go somewhere else, right? So on the left-hand side here, you've got me executing just from the kubectl CLI. I'm just getting all the secrets, right? And putting the output to JSON. And literally doing that not only gives me the metadata of the secrets, like their configuration, you get the value too. And this is what I was talking about with the data plane versus the control plane. It's kind of molded into one, which also makes it interesting to detect or a little more difficult, right? So the API call by itself doesn't have it. Basically, if you look at the object ref, there is no namespace in there. You see a verb of list, resource secrets, and that's basically what that activity looks like. So, okay, great. I turn this on. Now it's making tons of noise. How do we make it better? The first part is you will have to kind of go through an allow listing process of some of those Kubernetes or internal cluster components have a legitimate need to do this. Like there's certain components that are escaping my mind right now that watch secrets for updates. So that'll be the first one you'll have to allow list. Obviously, I mentioned namespacing, right? There's certain tools out there that developers use, like I think K8s or Lens, that will like kind of like visually list resources for you. And they do this, but they use label selectors and they discard the value. Also, historical context here, right? I think the same thing with Exec, with secrets here. If you've got a workload that's been running for a year, never done this, now it's suddenly doing this, probably worth a look. I think I almost made an accidental example of, you know, why to use an external secret store in Kubernetes land, because at least in my opinion, the data control plane coming from something like AWS Secrets Manager are just very weird, right? Usually separate APIs for reading the secret value versus administering it or looking at metadata about it. And you can really apply the same detection logic to config maps too. It's ideally not storing secrets in there, but you know, an attacker could look for interesting information in those to potentially move laterally. So awesome. So that's the talk. Thanks for hanging with me through it. I guess high level conclusion details, right? And it's always going to be important to, you know, while you can look at TTPs and MITRE ATT&CK and all that stuff, but you're always going to want to work backwards from the context of your environment or your org first. If you're using managed Kubernetes, just understand the different little intricate pieces and how that might influence this before you get too deep into it. I'm a huge fan of Kubernetes audit logs, and I quite frankly think they're underutilized for kind of protecting our side of the shared responsibility model. and gently yell at your CSP TAM and ask for better, cheaper options for using Kubernetes audit logs. Thank you.